So let's continue with what we were looking at last time. Remember what we did was we defined a function, so define h of x, and we define this function so that if x is even, and if that was the case, we wanted to return x over 2, and we're going to use the double division sign, so we forced integer arithmetic. Otherwise, we want to return 3 times x plus 1. And we define this function. If we hit shift enter, we define this function, and what we did was, if we have, say, num equals 5, and then we do print num, and then for I in range 20, we say num is updated, h of num, and then print num. Then this gave us these outputs that you see here. And so notice, first off, it's a little clumsy because we have to keep scrolling down to see it. So first off, let's see if we can fix that. And the way we're going to do that is we're going to capture the actual iterates. So we're going to say iterates equals, and we're going to use a list. And a list is just surrounded by square brackets, and the order is important. So we're going to start out with num as our initial value in the iterates, and then we're going to say for I in range 20. And so what we want to do is we want to keep adding the number to the iterate. So instead of printing it out, we're actually going to capture them in this list. So let's put in num equals h of num, but instead of printing it, we're going to append it. Now iterates is a list, so that means that it's got the append. And the way we can see that it has this append is in the IPython notebook. If you put a period after something that you've defined, then you can hit the tab key and it will show you the methods and properties that are associated with it. So let's click on append, and then if you put an open parentheses and hit the tab key again, then it will show you what that does. And so it says the append will append an object to the end of this list, and so we want to append the number. And then when we get done, we're going to print the entire collection of iterates. So let's see what happens here. We'll put num equals 5 again, and then if we execute that with the shift enter, so notice now we have all the iterates here, 5, 16, so on and so forth. But of course, now we want to notice that we can't quite get what we want, because this sequence actually has several repetitions of the 421, 421. But if we change this to, say, 31, as we did in the class the other day, and shift enter, then the 20 iterates gets nowhere close to the 421, 421. So let's change this. Let's go up here and put in a different kind of loop. And let's suppose we put in while the number is greater than 1. And so as long as this is true, then it continues continues to loop. But when this becomes false, in other words, when the number reaches 1, then we will actually stop at that point. So now let's re-execute this with that in mind. And notice now we have the iterates is 31, and there's a lot of them. In particular, we can do the length of the iterates, and we see that there are 107 is how long this collection of iterates is. Now if we keep going, we can do some other things. For instance, we can plot the iterates. So if we just put plot in here and then the iterates inside, then you can see we've got this sequence that looks like this. And notice it actually goes up quite high. And in some sense, people say that this reminds us of a hailstone. So a way a hailstone will get up and bounce around in the clouds and form the ice balls, and that's why this is known as the hailstone problem. And the iterates are known as a hailstone sequence. So let's do one more thing for right now. Let's suppose we take these iterates and let's do B and then O. And what this is going to do, it's going to plot the iterates again, but instead of connecting all these with these lines, it's going to use circles, and they're going to be blue. So now you can see that we have the same sequence, but as a collection of unrelated dots rather than being joined by lines. And so the first letter in this format string is the color. So K is black, and then you have different symbols. So if we do dot, then that's actually going to be a small point, as you can see here. And so you can see that we have that. If you want to get back to the connected, that's K minus, and there we're back to our connected hailstone sequence.